Math 3, Unit 10, Section 5. So today we're talking about radians. You can read this whole paragraph, pretty exciting stuff, but I think it's easier if I just explain things to you. Okay, so since radian measure is new for us, we will need to relate it to degree measures so we can understand it. We are dealing with a circle, and we know that the circumference of a circle, so the whole outside of the circle, is 2 pi r. Everybody agrees with that, correct? Okay, so in the unit circle, the radius r is always equal to 1, which we've been talking about, our unit circle, 1 unit. You know, this r right here, everything going across would be 1 unit. So the circumference of the circle is 2 pi times 1, because 2 pi r, 2 pi times 1. Make sense? Okay, therefore 2 pi times 1 is just 2 pi. So now we have a relationship between degrees and radians. 360 degrees equals 2 pi radians. Are we okay there? So the whole outside of the circle, in terms of radians, because our radius is 1, if you plug that into the circumference formula, okay, our radius is 1, 2 pi times 1 makes 2 pi. So our circle is 2 pi radians. Okay, so radians are dealing with pi, okay? They are saying that the angle on the circle is 6 pi over 5, okay? Or, yeah, 6 pi over 5 radians. We want to figure out where to draw this, okay? You guys with me so far? Okay, we know that the whole circle is 2 pi. So this is representing 0 as well as 2 pi at this point. Is everybody good with that? If we go halfway over here to 180, how much does this represent? Just pi. Okay? Is everybody okay with that?
Why wouldn't both sides be 2 pi?
So this starts at 0, okay? Goes around, you get here, this is pi. And then you keep going around, and when you get all the way around the circle, that is, I can't write it, 2 pi. Does that make more sense? Okay, so since half a circle is pi, how much would be up here? Pi over 2. Anybody know what would be down here? So this is half a pi, correct? This is 1 pi. It'll be 1.5 pi, right? Or 3 pi over 2. That represents 1.5. And then you add another half to that, and you would get 4 pi over 2, which reduces to be 2 pi. Okay? Now, going back to this one, because it's dealing with 5, I want to make these so they have denominators of 5. Okay? So instead of writing 2 pi, I'm going to write 10 pi over 5. Because does that represent 2 pi? Yes. And it will make more sense matching it with where 6 pi over 5 would be. Okay? So if this is 10 pi over 5, and I know this represents just pi, how would I write this side as a fraction with a denominator of 5? Good. 5 pi over 5. Are there any questions about that? Now, you don't always have to mark these ones here in the middle, but if you want to, just to help you out a little bit, you would just take half of this number. So what's half of 5? So this would be 2.5 pi over 5. And we know that we add this amount to this one in order to get this bottom one. So this one's going to be what? 7.5 pi over 5. And if you added another 2.5, you would end up getting to 10. Make sense? Yeah. Okay, so when we are drawing the angle in standard position, which quadrant will 6 pi over 5 be in? Very good. 3 is correct. So we're just going to draw that. We're going to make our line, and we're going to call this 6 pi over 5. Everybody okay so far? Okay, we know that's in quadrant 3. They want to know the reference angle. When we are finding the reference angle, what do we always do? We go up to the x-axis. We know that it will always be positive. Okay, and then it's always less than 90 degrees, which means that it's going to be less than 2.5. Okay? So how much is it going to take to get from here to here? Very good. 1 pi over 5, or pi over 5. Because we're at 6 pi over 5, and we want to get back to 5 pi over 5. So 6 minus 5 is 1. So you can write a 1 in front if you want to like help yourself remember. But that's 1 pi over 5. Okay. Questions? So we're going to practice again. Okay? So we know this is 0, but in terms of 2 pi, because this denominator is 9, we want our denominator to be 9. What would go on top? Very good. 18 pi, because that's going to reduce to be 2. The other side is going to be 1, but again, we want a denominator of 9, and so what will go on top? 9 pi. Is everybody good there? Do you guys want to go ahead and do the halfway marks on each of them? Just to be safe? We'll do it now in our notes, but in your homework, if you don't want to and you can figure it out, that's fine. So then what's half of 9? So this would be 4.5 pi over 9, and then we would add 4.5 to 9 in order to get this other halfway mark, which would make 13.5 pi over 9. So where is my 5 pi over 9 going to be? Quadrant 2. Very good. So we draw this. It goes to quadrant 2. We write 5 pi over 9. Quadrant 2. And then reference angle. So again, reference angle always goes to our x-axis. It's going to be less than 90 degrees. So that means it's going to be less than 4.5 over 9. Okay? So what does it take to get from 5 to 9? 4. Very good. So 4 pi over 9 is my reference angle. So the nice thing about radians is we're kind of dealing with smaller numbers. We're not dealing with these degrees and hundreds. But it's just different than what we've been doing. So degrees and radians mean the same thing. It's just saying it 2 different ways. Okay? All right. So next one. What number is going to go over here? So we want a denominator of 10. What would need to go on top in order for it to be reduced to 2? 20. So this is 20 pi. Over here, this is going to be 10 pi over 10. When we take half of 10, up here we get, good, 5 pi over 10. And in the bottom, perfect, 15 pi over 10. Does anybody have questions about writing this? Why did I use 10 on this one? Yeah, because this denominator is 10. So whatever our denominator is up here, that's what we're going to choose for the unit circle for the denominators on each of them. Okay? So 23 pi, what's going to happen with that one? Very good. It's going to go all the way around once, and then it has an additional 3 pi, correct? And so it's going to end up in which quadrant? Very good. Quadrant 1 is correct. So make sure that you do your whole little circle there, and then going back around, we make it here, and that is 23 pi over 10. Okay, we are in quadrant 1. And then reference angle. Show me on your fingers what the numerator will be for this reference angle. Good. Not everyone's responding, but those of you that are have it correct. Nicely done. Good job. So, again, always goes to the x-axis. I'm at 23. I'm going to the x-axis. How many is it going to take to get from here to here? 3. Okay, and remember, reference angles are always positive. It's always also going to be less than the 90-degree mark, and 3 is less than 5, so 3 pi over 10. Okay, are we good? Okay, next one. My denominator on this one's going to be what? 9. Okay, what's going to go on top of this side? 18 pi. Over here, on the left side, it's going to be 9 pi over 9. Half of 9 is 4.5 pi over 9, and then we add that and we get perfect. Okay, so which quadrant will 16 pi over 9 be in? Quadrant 4 is correct. Very good. So we loop this around. We get to quadrant 4. We're going to mark our reference angle. Okay, or sorry, we're going to our standard position angle. And then what does it take going up to the x-axis from 16 to 18? What will be that reference angle? Very good. 2 pi over 9 is correct. Sorry, I realized I should have made this bigger. Okay. Next one. What's different about this? Oh, yes.
If it's like it takes 2 pi over 8, can we reduce it?
Yes. Yeah, if you can reduce, you will. Thank you. All right, next one, negative. Okay, so let's first mark our unit circle. My denominator is going to be 5, so what's going to go on top here? Good, 10 pi. Over here on this side will be 5 pi over 5. Half of 5 is 2.5, so at the 90-degree mark, it's 2.5 pi over 5. And at my 270-degree mark, what would that be? 7.5 pi over 5. Mia? Yes, I totally agree. It's negative. So we should write these going the opposite direction, right? So I'm going to cross these out. Good job. You can have candy later. What? Yeah, so instead, and you know what? The only two that I'm going to change actually are these two. And so you start here, right? 0. We go down. This will be negative 2.5 pi over 5. And then this will be a negative 5 pi over 5. And this will be a negative 7.5 pi over 5. And then this is negative 10. So those two are going to be the same. It's just that when we're counting going down, because we're going the opposite direction, this will be a negative 2.5. Are we good? Okay, so which quadrant will negative 3 pi over 5 be in?
3.
Very good. It's going to end up in quadrant 3, so we're going to draw our standard position. This goes to quadrant 3. This is negative 3 pi over 5. Quadrant 3. And what would be my reference angle? And remember, reference angles are always positive. From 3 to 5, what does it take? 2. So 2 pi over 5. All right. Do you guys want to give this one a try on your own? Give you a minute here. So I'm going to go ahead and write just the radians on here. And I just realized I didn't give you a great example. We'll see if you guys get it. What happens when you get negative 5 pi over 2? Where does it go? Which quadrant is it in? So we have to go one loop all the way around, right? And that makes 4. And then what gets you to 5 is right here. Because negative 4 plus 1 more gives you negative 5. Do you guys agree? So this is one of those ones. It's called a quadrantal because that's in between two different quadrants. So it's called a quadrantal between quadrants 3 and 4. So it's not actually in a quadrant, it's in between two quadrants. Also, quadrantals don't have reference angles. So there's none. No. Ask me a question. So this is like that. Say they gave you that it was like ended on 270 degrees. You know, 270 degrees is exactly at this mark. Well, it doesn't say that. This negative 5 pi over 2 is exactly at this point. Negative 4 plus negative 1 is negative 5. So it's ending right here. It's not in between a quadrant. It is right here in between two quadrants. It's not inside one of them. Okay, so anytime that happens, it's called a quadrantal. There's no reference angle. It's just that point on the graph. So this would be like at the point 0, negative 1.
No, just confused because like how is negative 4 because the just goes in the middle down the 5. But that's 0, right?
So because this is negative 5, for this one, each quadrant is 1. So this went like negative 1, negative 2, negative 3, negative 4, negative 5. We can go back and talk through this later, but that's just... Do you want to ask me something? Are you sure? Okay. Can you explain it better?
No.
Okay. Anybody else? All right, let's move on. I'll come back to you in a little bit, okay? And show you another example. All right, complement. Do you guys remember what complement means? What's the complement? Okay, so it's normally two angles add to be how much? 90 degrees. Well, if we're dealing with radians, 90 degrees is half of pi, or pi over 2. So I'm going to write pi over 2 here. Supplementary is where you have two angles, and they add to be how much? 180 degrees, which is just pi, right? Half of the circle. In this case, pi. So they want to know you to find the complement of pi over 5 and the supplement of pi over 5. Okay, so the way you're going to think about this is you have pi over 5 plus, I'm just going to put x, because plus something, equals, and since this is 5, we want half of it, okay, which is going to be what? 2.5. Because 90 degrees is half a pi. Do you guys agree? Okay. So what's it going to take to get here? Now, if you want to, you could subtract. We could subtract pi over 5 to both sides. And what would you get? What's 2.5 minus 1? Okay, if I want to solve this, I'm going to subtract pi over 5 to both sides. I want to make sure you guys get this. Okay. So this eliminates, and for my complementary angle, I get x equals, what is 2.5? This is a minus 1. What is 2.5 minus 1? Very good. 1.5 pi over 5. Now, if you wanted to get rid of that decimal, you could. But let's just not worry about it. Is this good?
Yeah.
Okay, supplementary. Okay, so maybe you want to put a C here to remember that was your work for complementary. Okay, so I'm going to have to go up here now for supplementary. So supplementary, I have pi over 5 plus something equals, and on this one, what would I use to make it just pi with the denominator of 5? Yep, 5 pi over 5. Because that reduces to be just pi, correct? Okay, so then to solve this one, or if you set up this equation and you can figure out what this is without subtracting and doing all that, that is fine. Okay, does anybody know what the answer would be? Okay, you might want to put a 1 here. This might make it more obvious to you. But 1 plus what equals 5? 4 pi over 5 is the correct answer. Okay, if you're not sure and you want to go through the whole math process, which is great, I'm subtracting 1 pi over 5 to both sides. Again, 5 pi over 5 minus 1 pi over 5 makes 4 pi over 5. Okay, you guys ready to try the next one? I'm gonna have to try to write a little smaller to see if we can fit this in. So let's start up here, complementary angle. Okay, so we have 2 pi over 7 plus something equals, and we want it to be half of 7, which is what? 3.5 pi over 7. In your heads, are you capable of seeing 2 plus something equals 3.5? What is it? 1.5 pi over 7. For our supplementary angle, we have 2 pi over 7. We want to add something, and this time we want it to equal what? 7 pi over 7. So 2 plus what makes 7? 5 pi over 7. Okay, over here, complement. Okay, so we have pi over 6 plus x. For the complement, it's half of that. What is half of 6? So we have 3 pi over 6. What is missing? Yeah, so this is 1, right? 1 plus 2 pi over 6. Supplement. Again, we still have our 1 pi over 6 plus something equals 6 pi over 6. What am I missing? Very good. 5 pi over 6. And on this one, could I reduce 2 pi over 6? Yeah, and so if you can, you probably should. And we can divide by 2, and we get pi over 3. All right, any questions? Okay, next one. They want coterminal angles. Do you guys remember what coterminal angles mean? They end at the same spot, right? So remember, this is when we are like adding 360 or subtracting 360 in order to get to the right spot. Do you guys remember that? Okay. So, again, we are dealing with, and I'm 5 pi over 4, okay? In terms of 2 pi, what would 2 pi be for 5 pi over 4? If I was putting it on the unit circle. So if we're making our unit circle, over here would be 4, and what would go on top? 8 pi, right? Do you guys agree with that? Okay. So to get a positive coterminal angle, to go 360 degrees around it one more time to end up at 5 pi over 4, all we're going to do is add 8 pi over 4. Okay, so 5 plus 8 is what? 13 pi over 4 is a positive coterminal angle. What do you think I would do to get the negative coterminal angle? Subtract 8 pi over 5. And again, if you want to write these out, you could, but 5 pi over 4 minus 8 pi over 4 will give me what? Negative 3 pi over 4. And that is my negative coterminal angle. What will I be adding and subtracting for this next one? 12 pi over 6. So what would be my positive coterminal angle? 13 pi over 6. What would be the negative? Pi over 6 minus 12 pi over 6. And remember, that's a 1. What will that become? Negative 11, right? Good. Negative 11 pi over 6. Okay. On this one, what will I be adding and subtracting? Very good. 6 pi over 3. What will be my positive coterminal angle? 11 pi over 3. What will be my negative? Very good. Negative 1 pi over 3. Or you could just write negative pi over 3. Either works. Okay, what am I going to be adding to this one? 4 pi over 2. What will be my positive? 7 pi over 2. What will be my negative? Negative 1 pi over 2. Okay, questions? All right, this last part is just a review. See if you guys can remember any of it. You'll have some review questions on your homework. Okay, this first one, they're basically saying find the ordered pair on the unit circle for each angle. This is at 300 degrees. What quadrant is 300 degrees in? Quadrant 4, okay? So this is our 300 degrees. They want to know the ordered pair. What would be the easiest way to find that answer? Look at your unit circle. So if you get out your unit circle at 300 degrees, what is my ordered pair? 1/2 negative root 3 over 2. Now, you could figure that out by finding the reference angle, going up here. What would be the reference angle here? 60 degrees, okay? Based on that being 60 degrees, we know that across from 60 degrees is what? Root 3 over 2, right? Across from the 90, in this case, this one, because we're dealing with a unit circle, that's 1. And then up here, this is 1/2. And then we know that this is positive, but going down is negative. And so this is also how we're getting the ordered pair. On the x, it's going 1/2. On the y, it's going negative root 3 over 2, which gets you to that point. Okay? Shortcut, though, is unit circle. All right. Next one. They want to know this ordered pair. Okay, so right here on the circle, they want to know that ordered pair. We already know that the y value is 12 over 13. Based on this being 12 over 13, and this is a 90-degree angle, we're going to make the hypotenuse what? 13 over 13. Okay, and then we need to find this. How do we find that? What do we use? Very good. So we have a squared plus b squared equals c squared. Remember that we're only dealing with the numerators because all of the denominators are going to be the same, which will end up canceling them out. So 12 squared plus x squared equals 13 squared. 12 squared is what? Plus x squared equals, and 13 squared is 169. We subtract 144 to both sides. These eliminate. X squared equals 25, square root of both sides, and x equals 5. Therefore, this value right here is 5 over 13. And because it's going left, it's going to be negative. So what is my ordered pair? On the x, it's going negative 5 over 13, and on the y, it is going 12 over 13. And so that is my answer. Okay, last one. Here's angle A. They're asking us to find the sine, cosine, and tangent. In order to do that, though, we need to know this whole triangle. Okay? What I notice here right now is that I could set up a proportion in order to figure out how much this is. So we're going to do big triangle, See how you have the big triangle here? Yes? And then you have the small triangle. And this goes back to last unit where we can set up a proportion because these are similar triangles. Okay? So on the little triangle, I have this length right here is x over the height is 3. Does everybody agree with that? On the big triangle, the height is 7. And so that's going to match with what? The x or the 3? Very good. So we're going to put that on the bottom. And the big long length is what? 8 plus x. Because we'd add those two together. So in order to solve for x, we're going to cross multiply. So we have x times 7, which is 7x, equals, and then you have 3 times 8 plus x, which means I have to distribute there. So I have 7x equals 3 times 8 is 24. 3 times x is 3x. In order to solve, I will subtract 3x to both sides. This eliminates. I have 4x equals 24, which means x equals 6. Okay. So, the whole length of this bottom piece of the big triangle is how much? 14 is correct. So now that we have that, we need to know what the hypotenuse is in order to do sine, cosine, and tangent. How will I do that? We can use Pythagorean theorem. 7 squared plus 14 squared equals x squared or c squared, however you want to write that. We end up with 49 plus, and then 14 squared is 196 equals x squared. We add those together. We get 245 equals x squared. Take the square root of both sides. When you take the square root of 245, it is not a perfect square. You would end up breaking this down. This actually breaks down to be 49 times 5. So what would that be in terms of roots? 7 root 5. So this is 7 root 5. Okay, now we can do sine, cosine, tangent. So I have a 7 root 5, I have a 7, and I have a 14. Okay, we're dealing with A. So what is sine of A? 7 over 7 root 5. What happens there? Oops, you can't see what I'm writing. There you go. You have to rationalize it. Also, if you notice, these 7s cancel out. And so when I rationalize it, I'd multiply by root 5 to both the top and the bottom, and we'd end up with root 5 over 5 for sine of A. I need to make this smaller. Okay, there we go. Now, cosine A. What is cosine A? 14 over 7 root 5. Again, I can reduce. 7 goes into 14 2 times. But I have to rationalize the denominator, so I multiply by root 5. And we end up with 2 root 5 over 5. Okay, last one. Tangent of A is opposite, which is 7 over adjacent, which is, and that reduces to be 1/2. Okay, and that's it.